Hi, where are you watching from? Drop your city and country in the comments.
The atmosphere inside the subterranean laboratory of Vault 3 did not possess a natural humidity. It was artificially stabilized at exactly 20%, with the temperature held at a permanent, unyielding 20 degrees Celsius by 4 independent industrial climate units. The air carried no scent of grease or diesel smoke. Instead, it smelled faintly of isopropyl alcohol, ionized dust, and the sterile, metallic chill of nitrogen cooling lines. From the elevated observation window of the calibrator's annex, the polished granite inspection tables below looked like massive, black monolithic blocks, completely isolated from the seismic vibrations of the city above by 4-foot-deep rubber and pneumatic dampening cushions. I sat on a high steel stool near the primary optical comparator desk, my leather measuring aprons, heavy, dark with decades of fine diamond-lapping oil and lined with pockets for high-precision steel slip gauges, resting flat against my thighs. For 42 years, my official title within the National Standards and Metrology Directorate had been Master Calibration Arbitrator and Senior Material Defect Analyst for high-stress alloys. In the glossy investor presentations of the modern aerospace consortia, my laboratory was viewed as an expensive, slow, and outdated bottleneck from the early jet propulsion era. The new corporate manufacturing conglomerate, Apex Orbital Systems, had long since transitioned to using automated coordinate measuring machines, CMMs, blue laser surface scanners, and cloud-based algorithmic quality projections that treated a critical turbine shaft or a deep-sea pressure valve as a simple cloud of digital data points on a screen. They genuinely believed that precision was achieved by purchasing a more expensive laser and clicking a button on a desktop interface. But optical lasers do not calculate the microcrystalline stress changes that occur in an unaged titanium forging when a corporate production line accelerates the cooling cycle to save 11 minutes per unit. They don't see the tiny subsurface vacuum bubbles that form under the chrome plating when a machine tool is run 300 revolutions too fast to meet a quarterly delivery quota. I was the man who knew the precise tactile resistance of an absolute flat surface, the metallic ringing pitch of a zinc alloy casing that had been cooled too fast, and the exact micron tolerance a turbine blade could expand before it would fuse with its housing under centrifugal load. I was not a corporate venture capitalist, a software engineer, or a data analyst. I was a physical evaluator of physical dimensions, atomic structure, and mechanical tolerance who had spent half his life under monochromatic sodium light, reading the invisible flaws that the automated scanners were too blind to detect. My nephew, David, stood near the automated coordinate measuring machine, his crisp white cleanroom suit unblemished, carrying the chemical scent of fresh laundry as he synchronized his company tablet with a laboratory's local mainframe. He was 34, the regional director of manufacturing acceleration for Apex Orbital, a man whose entire professional career was defined by cycle time optimization, which in practical terms meant reducing parts testing windows from 4 days to 6 minutes, forcing material suppliers to skip the mandatory thermal stabilization periods, and threatening veteran lab technicians with immediate replacement if they delayed a military aerospace shipment due to minor structural inconsistencies. The digital compliance certification from our automated laser sweep is already uploaded to the Defense Agency's cloud server, Uncle Lawrence, David said, his voice flat, rhythmic, and filled with the swift, aggressive confidence of a man whose performance bonus was calculated by the production volume per hour. The automated CMM checked the dimensions of the turbine rotor for the deep-water propulsion system across 8,000 independent data points. The variance is less than 2 microns. The unit is mathematically perfect. Honestly, at 81, spending 4 hours with a manual micrometer and a bottle of Prussian blue dye just to check the gear seat is an absurd waste of your remaining physical energy. You're holding up our shipping dock. He was presenting my forced removal from the laboratory's quality roster not as a cold corporate eviction, but as a compassionate, protective retirement strategy designed for my health. This is the exact terminology of modern corporate liquidation. You do not tell an old master metrologist that his manual gauges are more accurate than your uncalibrated lasers. You tell him he is too fragile for the lab. The blue laser scanners only read the light reflected off the surface glaze, David, I said, my voice low, carrying the flat, quiet cadence of a man who spent his life working in silent rooms where even a loud breath could alter the expansion of a steel bar. The computer doesn't see the structural grain direction in the metal beneath the polish. The system was designed by the leading robotics firm in Munich, Lawrence, he replied, sliding his tablet into his leather portfolio with a swift, definitive snap. We don't need an old man looking through a magnifying glass to tell us if a piece of iron is straight anymore. We are on a 48-hour countdown to clear the final equipment block for the Oceanic Research Vehicle before the government contract review closes. My corporate partners and I have already finalized your residency package at the Crystal Valley Springs estate. It's a private luxury community in the hills with a continuous medical staff, heated floors, and absolutely no factory noise. What David left out of his brisk professional summary was the fact that his promotion to Senior Vice President of Global Manufacturing was entirely contingent on clearing the Oceanic rotor block before the end of the fiscal quarter, and that his personal investment fund had already shorted the stock of our independent laboratory to clear the path for an automated warehouse conversion the moment my office was cleared out. The structural friction between my physical experience and my nephew's corporate timeline reached a critical threshold exactly 20 days later, during the final inspection of the Titan 9 subsurface propulsion rotor. The component was a massive, single-piece forging of advanced nickel-titanium alloy designed to drive the main cavitation pump of a deep-sea research submarine operating at depths below 10,000 feet. To the regional management team, it was a high-value shipping asset that needed to be cleared through the laboratory within 12 hours to avoid a severe non-performance penalty from the Federal Oceanic Agency. To David, it was the final physical benchmark that needed to be certified before the corporate board arrived for the annual facility validation audit. He came down to the cleanroom airlock of Vault 3 on a freezing Thursday afternoon, his thin leather dress shoes stepping awkwardly on the sticky dust removal mats at the threshold. He was accompanied by a man named Sterling, the newly appointed director of quality streamlining, a 29-year-old business logistics graduate whose understanding of metallurgy was entirely limited to what he had memorized from data simulation slides during his management courses. Mr. Thorne, Sterling said, his voice carrying the high-pitched impatience of a man whose schedule was being disrupted by a laboratory technicality. We've reviewed the electronic telemetry from the automated CMM unit. The dimensional curve is completely green. The machine has confirmed zero tolerance deviation along the primary rotation axis. We need you to sign the physical master calibration sheet so the crane team can crate the rotor and load it onto the transport flatbed. He held out a plastic-covered clipboard with a digital signature pad attached, a legal document that would completely release the National Standards Directorate from any liability if the alloy failed or the rotor seized under the immense hydrostatic pressure of the deepwater trench. The automated CMM unit was calibrated using a steel reference sphere that has been sitting under an unshielded LED lamp for 3 weeks, Mr. Sterling, I said, keeping my hands inside the thick, oil-stained pockets of my metrologist's apron. The ambient heat from that lamp has expanded the reference sphere by 4 microns. Your machine is reading everything as perfect because its own yardstick is warped. David stepped directly between me and the quality director, his face flushed red against the white cleanroom walls, his voice rising sharply above the low, constant hum of the air filtration fans. Lawrence, let's drop the 19th century science fair routine right now. The calibration software compensates for thermal expansion automatically based on the room's thermostat. Every hour this rotor sits on the granite table costs the division $35,000 in logistics penalties. Your refusal to sign this clearance is a direct breach of your operational contract. If that signature isn't on the screen by 5 o'clock, Sterling and I will execute an emergency technical override under the Industrial Modernization Act. He stepped closer, his eyes narrowing into a hard, commercial stare that carried no trace of a nephew's regard. We know what you're doing, old man. You're trying to stretch out your final week of salary by playing the eccentric safety purist. But your time is up. If you don't clear this part, We will have facility security escort you out of the building for intentional sabotage of a government project, and your retirement healthcare package will be submitted for an immediate forensic compliance review. He leaned down until his breath fogged the glass of my optical loop case. The Crystal Valley complex doesn't take residents with a flagged federal compliance file, Lawrence. You'll be spending your winter in a state-subsidized room down in the industrial flats where the ground vibrates every time the heavy freight trains roll past. Sign the clearance and let the line move. The final confrontation did not take place within the clean, white air of Vault 3. It occurred 48 hours later inside the main executive boardroom of the Global Aerospace and Defense Underwriter Syndicate on the 60th floor of the Horizon Alliance Tower, a glass skyscraper that overlooked the commercial district like a giant, reflective obelisk. David had organized an emergency technical arbitration hearing, using a corporate transport service to bring me there as if I were an obsolete piece of laboratory machinery being brought before a board of corporate receivers. Chairman Vance, a senior industrial insurer whose entire career was based on calculating the financial cost of deep-sea and aerospace structural disasters, sat at the head of the long granite table. Next to him sat David, his laptop open to a high-speed simulation loop titled Project Precision, Accelerated Component Certification, and Sterling, who was quietly taking notes on a digital tablet. Mr. Thorne, Chairman Vance began, his voice low, dry, and carrying the absolute emotional coldness of a man who viewed human life as a simple variable in a compound interest table. Your nephew has presented a highly detailed, data-supported case for the immediate release of the Titan 9 rotor block. The digital metrics indicate that the manufacturing tolerances are well within safe margins. Your continued refusal to sign off on the calibration certificate appears to be based entirely on undocumented personal intuition and outmoded manual testing methodologies. The monitor on the boardroom wall flashed a 3D animation of the nickel-titanium rotor spinning smoothly at 4,000 revolutions per minute under a simulated hydrostatic pressure of 12,000 pounds per square inch. The screen glowing with a bright, reassuring green that indicated perfect stability. The simulation is running on the assumption that the alloy is completely homogeneous. Chairman, I said, rising slowly from my chair without using the armrests. I didn't reach for an external hard drive. Instead, I reached into my old leather case and placed 3 small, polished steel discs onto the granite table. Each disc was exactly 2 inches in diameter. Their surfaces covered in a strange, rainbow-colored oil sheen that indicated intense internal friction. In August of 1985, I said, my voice cutting through the silent air conditioning with the absolute clarity of a shipyard bell. The sister component of this rotor, the deep vent propulsion shaft, failed during its initial sea trials in the Pacific. The manufacturer's computers at the time stated the alloy had been cured to absolute perfection. But the computers didn't calculate what happens when you use high-speed automated diamond grinding to finish a nickel-titanium surface without allowing the metal to rest for 24 hours between passes. They didn't calculate the microscopic lattice slippage that occurs when the chrome plating traps thermal stress inside the core. David laughed out loud, a short, sharp sound of corporate irritation. The 1985 incident involved a first-generation alloy, Dad. The Titan 9 block uses a vacuum arc remelted compound with real-time acoustic monitoring during the forging process. The digital register shows the structural integrity is flawless. The digital register shows what the sensors recorded during the first hour of cooling, David. I replied, looking directly at Chairman Vance, whose eyes had suddenly locked onto the rainbow sheen of the steel discs on his table. Your inspection team didn't perform a manual interference test because they didn't want to spend the 8 hours required to clean off the synthetic preservative oil. If you order that propulsion system to be installed in the submarine hull tonight, the moment the vessel descends past 8,000 feet and the water temperature drops to 1.5 degrees, the physics of the zero tolerance limit will take over. The internal thermal stress that your laser scanners missed will cause the outer casing to contract faster than the rotor shaft. The entire cavitation pump will lock up within 4 seconds. tearing the engine mounts out of the hull and imploding the research submarine's primary pressure chamber. In the science of metrology, there is an absolute physical boundary known as the elastic limit, the exact point beyond which a metal crystalline structure can no longer withstand external pressure without permanently changing its shape. It is a physical reality that cannot be negotiated by an executive vote, amended by an insurance syndicate, or hidden by a marketing campaign on screen. I pulled a small black manual with a worn leather cover from my inside pocket. The original 1985 Federal Metrology Directory for Aerospace and Subsurface Materials, certified by the National Bureau of Standards and bearing the permanent restrictive red stamp Material Stress Exclusion number 902 Alpha. It was a physical document that existed entirely outside the company's cloud network, an original federal safety mandate that could not be deleted by an IT update or overridden by a municipal development waiver. Under Section 14 of the National Defense Industrial Safety Act, I said, placing the manual directly over David's laptop keyboard, any high-stress alloy component that shows evidence of accelerated thermal finishing without a certified 48-hour resonance rest cycle cannot be granted an international safety clearance for deep-water transit without a destructive core sample test. The exclusion on this specific forging compound is still active, gentlemen. I never cleared it, and the Federal Standards Board never rescinded it. The room became completely devoid of sound, save for the faint, high-altitude creak of the glass wall as a fresh wind gust hit the tower. Chairman Vance leaned forward, his manicured fingers lifting the old manual from the keyboard. He flipped to the page with the red stamp, his eyes scanning the technical signatures from 40 years ago with a cold, absolute focus. Is this exclusion still active in the Federal Regulatory Archive, Sterling? Vance asked, his voice dropping into a razor-thin whisper that signaled the immediate termination of his professional patience. Sterling's face had turned an ashen, translucent white. He was tapping his tablet screen with desperate speed, his fingers slipping on the smooth glass. I don't have access to the pre-digital regulatory files from the central office. Our system, it only displays the active commercial manufacturing updates from 2015 onward. The physical laws of metal don't live in your system, Sterling, I said, taking my manual back from the insurance chairman's desk. They live in a vault at the standards office. If your corporate team ships that rotor tonight before that exclusion is legally cleared, your insurance syndicate will be fully liable for every life lost and every dollar of the military asset when that hull implodes in the trench. Chairman Vance closed his leather portfolio with a sharp, definitive thud that sounded like a pistol shot in the silent boardroom. The insurance clearance for the Titan 9 component is formally revoked effective immediately. The rotor will remain in Vault 3 under an administrative emergency, hold until a full destructive core test can be executed by an independent federal safety engineer. David stood up, his face a distorted mask of panic and corporate fury, his executive composure completely shattered. Uncle Lawrence, you old lunatic, you've ruined us. The investment syndicate, they will call the primary manufacturing bonds tomorrow morning. We've already leveraged our entire corporate capital account against the shipping timeline. If that certificate is frozen, we're completely bankrupt by Friday. I didn't leverage your capital against an unverified structure, David. Your own arrogance did, I said, packing my steel reference discs back into my case. You assumed that because an old man spent his life under sodium lamps in a basement, his knowledge was obsolete and his codebooks were garbage. But a metrologist's job is to read the reality of the dimension, not the profit of the buyer. The financial collapse of Apex Orbital Systems was not a slow decline. It was a sudden, vertical liquidation that erased the company from the National Manufacturing Registry within 90 days. The Federal Oceanic Agency and the Defense Logistics Group withdrew their multi-million-dollar purchasing agreements within 48 hours of a federal safety team confirming the severe internal lattice slippage in the titanium forging. The cost of running a full thermal remediation cycle and remanufacturing the propulsion blocks exceeded $38 million, a capital expenditure that made the regional operations completely toxic to institutional investors. Without the expected delivery bonus from the government timeline to clear their outstanding secondary credit lines, David's partnership filed for Chapter 7 liquidation before the winter ice had formed on the laboratory air intake vents. His luxury corporate sports car was towed out of his suburban driveway in mid-January, a quiet financial repossession witnessed only by the local postal workers who watched the bank's agents load it onto a flatbed truck in the gray morning slush. David called the laboratory house line once during the spring thaw, his voice hollow, flat, and completely stripped of his former corporate cadence. He spoke for less than 2 minutes, asking if I could use my standing as a lifetime member of the Metrology Directorate to help him secure an entry-level position as an assistant calibration checker on the low-priority agricultural pipelines in the Southern Flats. I told him that the pipelines were using automated drone sweeps now, and that the computers had no operational space for an executive who didn't understand how to read the physical expansion of a metal bar. I was not moved to the Crystal Valley Springs estate. The National Standards Board quietly canceled my retirement notice the following Monday afternoon. They realized that without my specific, physical understanding of high-precision materials and the undigitized alloy exclusions, they couldn't certify a single critical component in the aerospace or maritime sectors without risking a structural failure that would void their national insurance policy. They created a permanent position for me, Chief Metrological Arbitrator and Historical Material Integrity Custodian for the Federal District. My salary is now paid directly out of the nation's core infrastructure security fund, more than enough to keep my laboratory warm through the winter storms without ever needing to look at a corporate senior community brochure. I still sit on my high steel stool in the calibration office of Vault 3, watching the digital telemetry lines flicker on the automated CMM screens below. The machines operate under my supervision now. Their lasers cross-checked every morning against my physical slip gauges, and the titanium components leave the floor at a slow, measured pace, their surfaces resting for 48 hours until the metal crystalline structure has found its perfect, permanent peace. The younger generation operates under the dangerous, modern delusion that technology is the same thing as control, and that a three-dimensional animation can force the metal to ignore the laws of physics. They believe that success is a matter of simply accelerating the schedule and erasing the manual safety margins of the past to maximize a quarterly return. But they do not understand that the pressure does not look at your investment targets, and the titanium does not care about your promotion timeline. Every commercial empire, every high-tech fortune, and every family dynamic is ultimately subject to the physical limits of the material below. My nephew thought he was optimizing a slow asset when he tried to clear away my experience and force me out of the lab. He didn't have the functional capacity to understand that the old, quiet man he viewed as an operational bottleneck was the only structural anchor keeping his entire world from being torn apart by the weight of the deep ocean. In the end, he wasn't defeated by a father's anger or an elaborate legal conspiracy. He was simply broken by the unyielding laws of the zero-tolerance limit he refused to believe was real.